Okay, in this tutorial, we're going to consider how to answer this atmosphere question from the higher geography course. Now, this question has got two parts to it, and we should pay attention to the fact that we have 8 marks available. The first part is quite a simple part. It's just describing the pattern of the circulation cells and the winds, the associated surface winds. The second part, which is slightly more complex, is how that the winds cause a redistribution. Another idea is spreading of the energy from around the globe. Now, before I unpick this question for you and show you exactly what you should be looking to write, and actually hopefully showing you that this is a remarkably easy question to answer, let me just have a little look at a key theme that this question is based on. Now, if we have a look at this image of the planet, we have the equator at the center, and one of the ideas that you will have learned is that the equator, this belt around the center of our planet, receives much higher levels of solar insolation. And another part of the higher atmosphere topic asks you to be able to explain why that is the case. This question, however, is to do with how do the different cells of the planet and the surface winds cause this excess of heat at the equator to be moved to more northerly latitudes, for example, the North Pole. Okay, so what is their role in ensuring that heat energy is transferred northwards? Right, let's have a little look at this question. Right, we are given a diagram to start with, and we're shown that it is split into these zones, okay? And the first thing you're going to be wanting to consider is, and it's quite important to remember this, is the name of the 3 key cells. So here we have the Hadley cell. We have the Ferrel cell. And then we have the polar cell. That's a very important part in order of getting all of these described marks. Now, the first thing you're going to want to actually say is tell me about the role of the atmospheric system in moving heat around the planet. So we can see we've got these arrows in the southern hemisphere. I'm going to focus my answer on the northern hemisphere. So it's this section north of the equator. And the first thing I'm going to tell the examiner is that in the Hadley cell, warm air is moved from the equator to 30 degrees north. Okay, and in the Ferrel cell, air is transferred from 30 degrees north to 60 degrees north. And in the polar cell, heat energy is traveled from 60 degrees north to 90 degrees north. Or you can actually say cold air is transferred from 90 degrees north to 60 degrees north. And I'll show you what you should write in order to get those marks. Another key theme is the surface winds. Now, the surface winds are shown by these arrows. Okay, so if I was talking about the polar cell, I would want to be saying that there are trade winds, and that's the name of the winds given to the ones that blow from 30 degrees north to the equator. They're known as trade winds, and that they travel in a southwesterly direction, and we can see that those winds are blowing to the southwest. In contrast, from 30 degrees north to 60 degrees north, we have winds sometimes known as the westerlies, and these are actually moving heat energy across the surface from 30 degrees north to 60 degrees north. In our final cell, in the polar cell, we have these easterlies, and they are transferring cold air from the pole down to 60 degrees north. And that is pretty much what you're going to want to write. So here is the typical kind of model answer you'd want to put together to answer this. So we have the Hadley cell. It's identified there in this piece of writing, and it's formed between the equator and 30 degrees north, and you notice there's 1 mark given for that. And that the winds, the surface winds, well, they're known as the trade winds. That's a kind of key idea to remember, and that they move air from 30 degrees north back to the equator. And the key bit here is in a southwesterly direction, and you get another mark for that. Let's move down to the Ferrel cell. It's formed between 30 degrees north and 60 degrees north. There's a mark for that bit of knowledge. And the surface winds, they're known as westerlies, and they move air across the surface in a northeasterly direction from 30 degrees north to 60 degrees north. And we get a mark for that. Finally, we've got the polar cell. It's made from sinking air, and it moves southwards from 60 degrees to 60 degrees north. So from the pole, which is 90 degrees, to 60 degrees north. There's a mark. And finally, the surface winds, they're known as polar easterlies, and they take cold air from the pole, and they move it across the surface to 60 degrees north. Right, now when you look at all of that, there's 6 marks there. Now you could only get a maximum of 5, really, in an 8-mark question for just that description. There is a little bit extra you could add. These 3 cells, the 3 of them together, they're causing warm air from the equator to move to cooler latitudes. So that's a key part, and as a matter of fact, probably the most important idea of this is that the 3 cells are the big transfer systems that take that excess warm air that you find at the equator and move it to those cooler, higher latitudes. For example, where the UK is, around about 60 degrees north of the equator. Likewise, the colder air that builds up at the pole, well, it gets transferred down to warmer, lower latitudes. And notice, did you write these 2 things, you'd actually get credit for them. But once again, once you've achieved your 5 descriptive marks, that is as much as you can get. So let's have a look at the final 3. Now, there's lots of ideas that you can write to get your additional marks. One of them is, why do we have this deflection of winds? So let's just have a little look back. You'll notice that winds, rather than traveling directly back to the pole, like these red arrows that I'm drawing show, they're not. They're deflected at an angle. And that's all to do with the simple fact that our planet spins. So the first idea is that winds are deflected always to the right for the direction they're traveling. So wherever they're traveling on the Earth, they're always bent round towards the right. And that's because of this thing called the Coriolis effect. Definitely worthwhile remembering the Coriolis effect, remembering that key word. And that's the thing that causes winds to be deflected to the right on the planet, which is what gives them their direction. Another key point that you could think about is, why do we have surface winds in the first place? Well, wherever you have rising air, you get high pressure forming high up, and at the surface, you end up with low pressure. So likewise, when air sinks, you get the opposite, okay? You'll end up with high pressure at ground level and low pressure high up. So let me just have a quick little look at the diagram to kind of show you this. If I go to the map of the world. So because we have huge amounts of rising air at the equator, you end up with low pressure. I'm just writing LP there. And this air then travels to 30 degrees north and sinks at that location. Therefore, because there's lots of sinking air here, we end up with high pressure. Whenever there's a difference between 2 places with high pressure and low pressure, wind will always travel towards the low pressure area from the high pressure area. However, because the world is spinning, this is a high pressure area too. This is low pressure. Because the world is spinning, those winds get deflected to the right. And of course, the opposite happens in the southern hemisphere because we have a high pressure area down here. So we have a little look at how that looks when you write it. Surface winds are caused by traveling air from high to low pressure. For example, from the high pressure area of 30 degrees north, found in the tropics, back to the equator, which is an area of low pressure. So there's a bit of explanation. Why do winds happen in the first place? Because air is traveling from areas of high pressure to low pressure. What creates that? Well, if we bring in this idea that the difference in air pressure is created by these surface winds is caused by either warm air rising, which I just explained to you a second ago on the previous diagram, it's caused by heating at the equator in a process known as convection. So what's happening here with air rising away from the equator, that's convection, as in a convection current. So warm air is rising. So you get marked for that, identifying that process, with cooler air sinking at 30 degrees north, okay? Now, that process of warm air rising and cold air sinking means that the Hadley cell is what we call a thermally powered cell. So it's heat, which is driving the movement of air between the equator and 30 degrees north. Now, we have the opposite happening at the pole. This place, it's so cold up there that the cold air is sinking at the pole and then travels southwards. There's a mark, okay? And the polar cells, therefore, also thermally powered, but this time it's the opposite. It's cold. It's driven by cold air sinking and moving southwards. Now, caught in between it is this little ferrule cell. Now, it's not a thermal powered cell. It's powered by the other two, which means it's ended up getting called a thermally indirect cell, sometimes also known as a mechanical cell. And it's actually powered by air transferring from the other two. So that's the polar and the Hadley cell. So there's a mark there. Finally, the cells and the surface winds transferring surplus energy from the equator to areas deficit at the poles. Now, we actually brought that idea in as a descriptive point. So if you brought it in as an explanation point, you wouldn't get double credited for it. You will notice there's more than 3 marks here. There's actually more than 5. And if we go back to the question, it is only worth 5 marks. So depending on how many descriptive points you made would impact on how many explain points. But I've just shown you a model answer and given you some insight into how to approach answering.